Hello everyone, and once again welcome to my channel. And in this today's video I am going to continue with the paper solution, checkpoint paper solution. The paper number is 0862, and this is paper number 1. Okay, and this is October 2024 paper. All right, so this is a checkpoint paper, and I have already solved question number 1 to question number 14 in a previous video. So in this video I am going to solve questions from question number 15 till the last. I think there are up to 24, question number 24. Okay, so let us get started. Let us start with the question number 15. Now question number 15 says that Yusuf draws this table to record the length of each leaf in a sample of the leaves. Okay, so the length of the leaf he has taken in this way: L less than 10, then here it is 10 less than L less than 20, and here it is 20 less than L less than 30, and here it is L greater than 30. Okay, this type of table he is trying to make. But then the question says that Yusuf has made some mistakes in the class interval. So you can see that here in the class interval he has made some mistakes. Okay, now what are those mistakes that we have to identify? So write down the class intervals that allow Yusuf to record every leaf length to have been done for you. Okay, so this he is saying in the question, this class interval all are not correct. Okay, and you have to do some correction in 2 of them. They have done the correction in 2 of them. They have done the correction. You have to do the correction in the remaining 2. So the first correction is L less than 10. He has kept it as L less than 10. So there was no mistake there, right? And here can you see L greater than 30? He has made L greater than equal to 30. Okay. But these 2 corrections is already done by Yusuf. Okay, 2 has been done for you. So the rest of the things you have to see. Okay, now what is the fundamental principle over here? This class intervals, they have to be such that, suppose you take L less than 10, the first class interval. So in this class interval, all the numbers say from 1 to 9 will come in this particular class interval. Okay, all the numbers in the observation table which fall under the which fall between 1 to 9, okay, will come in this class interval. What about 10? 10 will not come in this class interval. 10 will not come in the first class interval. Okay, so 10 should go in the second class interval, obviously. Okay, so this 10 should go in the second class interval, and for that your 10 should be less than equal to L, or you can say L should be greater than equal to 10. Now it should be greater than equal to 10 because it should include 10, right? It should be equal to 10 as well as greater than 10. Why it should be equal to 10? Because in the first class interval 10 was not included. So in the second at least it should be included. So in the second class interval you will have to make this correction. 10, here it was less than L, so make it less than equal to L. This means that L is greater than or equal to 10. Okay, and then less than 20, let it be less than 20 only. Less than 20. Okay, now what is the meaning of this second class interval that we have corrected? All the length between, now this I am writing this way. Now meaning of this is all the length, all the observations from 10 to 19 will fall in this class interval. But if the observation is 20, that will not fall in this class interval. Okay, so where it should go? It should go in the next class interval. So obviously in the next class interval you should write 20 less than equal to L less than 30, isn't it? So let me write that: 20 less than equal to L less than 30. Now what is the meaning of this? All the numbers from 20 including 20, because this is L greater than or equal to 20. So if it is 20 also, it will be included in this class interval. So L will be 20 and up to 29. 30 is not included. See, it is less than 30. So only up to 29. If 30 comes, it should go to the next class interval. Okay, so here you should get L greater than equal to 30, because here 30 was not included, so it has to be included in the next class interval, which he has written here, L greater than equal to 30. So our answer has to be this. Okay, so I've showed you the working, how it works, and this is the answer. Got it? So that was question number 15, how to solve it. Now question number 16. Let us work out this 1 minus a 7 upon 10 divided by a 7. Okay, now give your answer as a fraction in its simplest form. Now this is a very straightforward simple question by its look, but then if you don't follow BODMAS, you are going to make blunder. Okay, now what is BODMAS? BODMAS means division will come before subtraction. Division will come before subtraction. As you can see here, there are two operations, division and subtraction. So first you have to do the division operation. Okay, so 1 minus 7 upon 10, this divided by 10, I'll write it as multiplication of 1 by 7. Right, this 7 will cut, so I'll be left with 1 minus 1 upon 10. So division operation I did first. Okay, now I can go ahead with subtraction. So 1 minus 1 upon 10 is nothing but 10 ones are 10 minus 1 upon 10, which is equal to 9 upon 10. So my answer should be 9 upon 10. This is the right way of doing it. Okay, follow the BODMAS theorem. Now B part of this question is 1 3 by 5 into 4 1 by 8. You have to multiply, and you have to see that this mixed number is in its simplest form. Now what we will do, 1 3 by 5, I can write it in the improper fraction. Okay, 5 1 5 plus 3, 8 upon 5 times this 4 1 by 8, I can write in improper form as 8 4s are 32 plus 1, 33 upon 8. Okay, so what I did, this 1 3 by 5, which was a mixed fraction, I converted into improper. 4 1 by 8 was a mixed fraction, I converted into improper, and then I multiplied these two improper fractions. 8 gets cut away, and I get straight away 33 upon 5. But he was the answer in a mixed form. Okay, so what I'll do, 33 upon 5, I'll just divide 33 by 5. 5 into 6 is 30, right? Remainder is 3. That's it. So my answer should be 6. Then I'll take 3 divided by the divisor 5. Now this is my answer, 6 3 by 5. Okay, and this is in the simplest form. Right, that was question number 16. Now coming to question number 17. This is, you have to solve the simultaneous equation. 3x plus y is 14, 5x plus 2y is 25. Now I will be doing by elimination method, but for elimination method I have to see that one of the variable is getting eliminated. So I'll try to see that y is getting eliminated, and for that to happen, I'll multiply this equation 1 by 2. When I multiply equation 1 by 2, I get 3x into 2, 6x, plus 2 into y, 2y, plus 14 into 2, 28. I get this equation. And second equation I'll keep as it is, 5x plus 2y equal to 25. Now doing this, what happens is this 2y and 2y can be eliminated now. So when I subtract, okay, when I do subtraction, 6x minus 5x is x, 2y minus y is y, 2y minus 2y is 0, and 28 minus 25 is 3. So I'm straight away getting x equal to 3. So I got the answer for x equal to 3. Now this x equal to 3, I will resubstitute in this equation. So it will be 3 times 3 plus a y equal to 14, isn't it? So this will be 9 plus y equal to 14. So y will be equal to 14 minus a 9, which is nothing but y is equal to 5. I'm getting the answer as 5. Got it? That was question number 17. Question number 18. Now this is, it looks to be very straightforward, but it's little tricky. Okay, so in this diagram you can see triangle ABC. ABD is a straight line. Okay, and angle X is acute and angle Y is obtuse. So this is a condition that is you have to take care of. X should be acute and Y should be obtuse. Find one possible pair of values of angle X and Y. So he is asking me to find one possible pair of the values of X and Y. Obviously this means that there can be many possible values. Okay, more than one possible value, right? So what I can do is now looking at this triangle ABC, I can tell you one thing is x, okay, should be always less than 80. Okay, because if x is 80, 100 plus 80 will be 180. Okay, and this angle will become 0 in that case. Okay, so if x is 80, this 2 itself will add up to 180 and this angle will become 0. And if this angle, that is CBA, if this angle becomes 0, this angle, okay, if that becomes 0, then this triangle will collapse. Okay, so for that you have to take x value always less than 80. So this is the first condition that I will follow. Okay, x should be less than 80. Second condition that I will follow is my y plus x should be equal to 180. Okay, so y plus x should be equal to y should be equal to x plus 100. One second, y will be equal to, one second. Yeah. So my second condition will be the exterior angle theorem says that y should be equal to, this y must be equal to x plus 100, isn't it? This is my second condition. Both this condition has to be satisfied simultaneously. X should be always less than 80 and again your y should be equal to x plus 100. Okay, this is by exterior angle theorem. Y is equal to x plus 100 and x should be less than 80. I explain you why. Okay, so now think of any number x, then x should be less than 80, and one more thing you have to see that x is a cube, so it should be less than 90. Okay, so we have to take less than 90 means you cannot take it as 89, okay, or 88, because your x should be less than 80 also. So this is the main condition. This condition he has given you, x should be, x is acute. Acute can be anything less than 90, but our modified condition is x should be less than 80. So let me take x as 50, that should work. So let me take x equal to 50. Now when x is equal to 50, what should my y be equal to? Y should be equal to x, I'll put 50 and plus 100. My y should be equal to 150. So these are the two possible values which are satisfying both these conditions. Okay, if x is equal to 50, x less than 80 condition is satisfied, and if x is equal to 50, y is equal to x plus 100 is also being satisfied. So this has to be correct, 50 and 1, right? So this is one pair of answer, but as I told you, there can be many answers to this. Okay, suppose I'll give you one more pair so for you to understand. Suppose my x is say less than 80, you have to take, isn't it? Suppose I am taking this x as 24. Okay, somehow I am taking x as 24. It is less than 80, so I can take. Now the second condition will become y is equal to x plus 100. So it will be 24 plus 100, right? So y should be how much? 124. This should also satisfy. Okay, so my other pair of answer will be x equal to 24 and y is equal to 124. Even this answer is correct, even this answer is correct. So what I mean to say is that there will not be a unique answer to this. Okay, any pair of x and y will be working, but the thing is this conditions has to be satisfied. So x equal to 50 and y equal to 150 is a correct answer. X equal to 24 and y equal to 124 can also be a correct answer, and that way there can be many more correct answers. Okay, let us go to the next question. This is question number 19, and it says that the diagram shapes A and B are okay, and the diagram shows shape A and shape B on the coordinate grid. So this is the diagram A and this is this diagram B. So on the coordinate grid they have shown you this two diagrams. Okay, what further question says is shape A, that is this one, is transformed onto shape B. So A is transformed onto B by a combination of two single transformations. So A is an object which has been transformed once, and then again that image is transformed second time to give you the final image B. So A has been transformed not once but twice to give you B. That is the meaning of combination of two single transformations. Okay, So A has been transformed not once but twice. Okay, so there are two transformations taking place on A successively to give you B. That is the meaning of it. Now the first transformation, he says, is a rotation of 90-degree clockwise about 0, 0. So the first transformation that takes place on this A is a rotation of 90-degree clockwise, and the center of rotation is 0, 0. So this is the center of rotation. Okay. Now this is very straightforward. If you want to draw the image of this first transformation, after first transformation, what will be the image? So what do you think about this in this way? This is your object, right? Take this side, okay, this side, which is on the x-axis, the horizontal side. Okay, turn it by 90-degree clockwise. So you'll have to turn it this way by 90 degree. So this particular side will come onto this. Okay, can you see this point will come to this point? Okay, fine. Now this vertical line, when it gets transformed, when it is moving 90-degree clockwise, this vertical line will become horizontal and it will fall over here. So this point, can you see this point, that will come over here. Okay, so you got the 2 points. Now what about this line? Can you see this vertical line? This vertical line, okay, on rotating 90-degree clockwise. Okay, so this will be rotated 90-degree clockwise and it will come here, this way. Okay, so this particular point is this point. Got it? So these 3 points, okay, the corresponding image I have drawn here. Okay. Now all you have to do is join these points to get the figure, which is after the transformation 1, that is rotation of 90-degree clockwise. Okay, so let me do that. So this will be that figure. Okay, right. So this is that figure. Okay, so this is my result after the first transformation, right? This one. Now what happens? Okay, now he says describe fully the second transformation. Now this is the result of the first transformation. Now describe the second transformation. So second transformation, to describe second transformation, you'll have to observe these two. Okay, now what you can see between these two? I can see that between these two there is a reflection taking place. Okay, and where the reflection is taking place, I think it is taking place along this line, which is the mirror line. Okay, so I think this is that line. Okay, roughly this is that line. Okay, this is the mirror line. Now if I want to name this mirror line, so can I write it as this is parallel to y-axis, so it will be x equal to, and this passing through -1. Okay, so mirror line is x equal to -1, and the transformation is, you can see very clearly, it is reflection. Okay, so 1 is getting transformed to B. Okay, in the second transformation, 1 is getting transformed to B by reflection along the mirror line x equal to -1. So that's the answer for this question. Let us move on to the next one. Write the letter for each calculation in the correct place on the Venn diagram. So there is some Venn diagram given over here. You can see this is the outer circle. Here it is written less than 8 raised to 6. This is another circle Venn diagram. This is greater than 8 raised to 6. And in this you have one more circle which is equal to 1. Okay. Now this question is pertaining to, I think, exponential forms. Okay. So if you are good at exponents, you can do this question very easily. Now first card A says that it is 8 raised to 2 into 8 raised to 2. Okay, 8 raised to 2 into 8 raised to 2 is 8 raised to 4. Now how I did this? Because I know the laws of exponents. Okay, so 8 raised to 2 into 8 raised to 2 is 8 raised to 4. Now where I will be putting this card? Now it will be definitely not in this particular Venn diagram, because this is for greater than 8 raised to 6. We have got 8 raised to 4, which is less than 8 raised to 6. So I can put this card which is 8 raised to 4, equivalent to 8 raised to 4, somewhere in this. So let me put in this circle. Okay, so here I'll put my A. That is already put by him. Okay, so let us go to B. Now B is 8 square into 8 cube. Now this will work out to 8 raised to 5. 2 plus 3 is 5. Okay, again this B will come in this circle only, because this is 8 raised to 5 is less than 8 raised to 6. So I will put my B over here. Okay. C is what? It is 8 raised to 15 divided by 8 raised to 5. So 8 raised to 15 divided by 8 raised to 5. The law says that it should be 8 raised to 15 minus 5, which is equal to 8 raised to 10. Okay. And 8 raised to 10 is obviously greater than 8 raised to 6. So my C, 8 raised to 10, will come in this. Okay. Then D is 8 raised to 0. Okay, now you know that anything raised to 0 is equal to 1. So 8 raised to 0 has to be 1. So my D card will come in this circle. Okay, this is equal to 1. So my D will come in this. Okay. What about E? E is 8 into 8 raised to 5 into 8 raised to 1. Okay, so this will be 8 raised to 5 plus 1, 6 plus 1, 7. Okay, 8 raised to 7. So 8 raised to 7 is something which is greater than 8 raised to 6. So E will come in this. Now what about F? F is 8 raised to 2 whole raised to 3. Now 8 raised to 2 whole raised to 3. This works out to 2 into 3 is 6. So 8 raised to 6. Okay. So this is 8 raised to 6. Now 8 raised to 6. Can it be in this circle? No. Because this circle is for greater than 8 raised to 6. This circle is less than 8 raised to 6. So 8 raised to 6 cannot go in this circle as well. Okay. So it will neither go in this nor it will go in this. It will lie outside both of this. So your F card will be outside this two circles. Okay. In this region. Okay. So that is how you have to place these cards in the Venn diagram. That was question number 20. Question number 21 is Jamila writes these rules about the fraction and their decimal equivalence. Okay, tick mark whether it is true or false. Okay. Now fractions with an even denominator will always be equivalent to a terminating decimal. Okay. Now she says that fraction with some even denominator. So let me take the even denominator as 2. Okay. And numerator she has not given any restriction. So let us take 1. Okay. Now 1 upon 2 is equal to what? 0.5. But 0.5 is what? It is a terminating fraction. Okay. It is a terminating decimal number. Why? Because 0.5, if you divide this 1 by 2, you will get the remainder as 0. Okay. When you do this division, you will get a remainder as 0. And the division will stop. You will get this as a terminating decimal. This is known as a terminating decimal. So according to Jamila, okay, the fraction with a denominator even number, so I took even number as 2, and 1 upon 2 works out to 0.5, which is a terminating decimal. She is telling you that fraction with an even number will always be equivalent to a terminating decimal. So here I am getting, okay, by doing this example, I am getting a terminating decimal. But let us see whether this is true for all. Okay. Now let us take 3 by 4. Okay, 3 by 4. Now 3 by 4, this 4 is a even number, denominator, and 3 is a any number I am taking in the numerator, 3 upon 4. Now when I take 3 upon 4, I get 0.75, and this is also a terminating decimal. Okay. So by taking 3 by 4, in which 4 is a even number, in the denominator I have taken even number, I am getting still a terminating decimal. 0.75 is terminating decimal. But still, I don't think we should jump to the conclusion that she is right. Okay. Now, if I do 3 over a 2, what I am doing? 3 over a 2. So in the denominator, I am taking 2, an even number, which she has told us to take. Okay. But in the numerator, we have the liberty. So I am taking 3. And 3 upon 2, I am getting as 1.5. But this is also terminating. Okay. This is also terminating. Right. So if you can find even one particular fraction, which even one fraction, okay, which does not follow this particular rule, then it will be a false statement by this Jamila. Okay, so let us try to find out at least one number, one fraction which is not terminating, right? And according to me, that happens to be 1/6, right? Now 6 is an even number, and 1/6. Now if I try to divide 1/6, okay, 1 divided by 6, how I'll do the division? I'll do 0, decimal, 0. Okay, now 6 ones are 6. Okay, so 4 and 6 are 36. Okay, 6 7 is 42. 6 are 36. So again I'll get a 4, and again 6. So this will go on. So if I try to divide 1 by 6, I will not get a terminating decimal. Instead I will get a recurring decimal, 0.1666. This, okay, this can be written as 0.16 with a power on that 6. So this is an example where I have proved that Jamila is not true, or Jamila's statement is false. Okay? And one statement was enough for me. Okay, so even by taking 6 as an even number in the denominator, still I am getting a number which is non-terminating. Okay, it's recurring. Now let us see in this statement, if the fraction is a multiple of 9, the denominator is a multiple of 9. Okay, multiple of 9 are what? Multiples of 9 will be 9, 9 2s are 18, 9 3s are 36. All these are multiples of 9. Okay. Now if you take multiple of 9 in the denominator, and then if you try to find out a fraction, it is equivalent to a recurring decimal. Now let us do that. Okay. So suppose you do 1/18. Okay. This 18 is a multiple of 9. Okay. And 1/18 if you try to do, then this 1/18 is a non-terminating fraction. Okay, it should work out to around 0.0555. It will go on. Okay, this can be written as 0.05 and then a bar. Now this is also not terminating. Okay, or this is equivalent to a okay. Here it says is always equivalent to a recurring decimal. So in this case we are getting a recurring decimal. Okay, but then we should not be happy with this. Okay, try to find out even if you get a one number, one particular fraction which is not a recurring, then we will prove this also to be false. Okay, so suppose I take 18, okay, divided by 36. Now 36 is a multiple of 9. So he has told us that multiple of 9 can be taken as a denominator. But now I am taking this numerator as 18. So 18 upon 36 happens to be 1/2. And 1/2 is nothing but 0.5, which is a terminating. It is not recurring, it is terminating. So here I have made you see that this Jamila statement is not correct here. So every time it will not be recurring decimal. See, here you are getting a terminating decimal. So even this statement is false. So for both the boxes, okay, I'll have to put tick mark on the false. I hope you understood this question. Question number 22. Naomi has a bag containing 5 counters. So she has a bag containing say 1 to 5 numbers. Okay, 1, 2, 3, 4 and 5. And she has each with a different number written on it. So okay, I've written 1, 2, 3, 4, 5 different numbers. She also has a bag containing, so she has one more bag, and in this bag she has 10 counters, each with a different letters written on it. So suppose the letters written on it are A, B, C, D, E, F. How many? 10. So let me go up to J. A, B, C, D, E, F, G, H, I, J. Okay, so these are 10 letters, different letters in this bag, and in this bag she has 5 different numbers, 1, 2, 3, 4, 5. Now she picks up one counter at random from each bag. So one of the possible outcome is 3 and F. Yeah, that's possible. So from here, if she picks up one counter, she may get a 3. And from here, she may pick up and she may get a F. Okay, so 3F is one of the possible outcome. So that is what hint he has given. Now find the total number of possible outcomes. So this way, what will be the total number of possible outcomes? One of the outcome he has given you, for example, as 3F. So 3 from the first bag, F from the second bag. So here you have to try to draw a tree diagram from the first bag. Okay, the possible, suppose that first bag is containing numbers from 1 to 5. So the possible outcome can be 1, 2, 3, 4 or a 5. Okay, this is from the first bag. Now from the second bag, okay, having chosen 1 from this first bag, now from the second bag she has an option of how much? 10 letters, A to J. A to J. Okay, so your possible values will be 2A, okay, sorry, 1A, then 1B, 1C, 1D, up to 1J. Now this will make it 1, 2, 3, 4, 5, 6, 10 possibilities. Okay, so this is 10 possibilities from here. Okay, then from 2, 2A, 2B, 2C, 2D, up to 2J. From here also there are 10 possible outcomes. Okay, so 2 and then any one of the 10 letters. From here also there will be 3A, 3B, that way 10. So that way if you see, it will be 5 times 10, that is equal to 50. The total outcome possible will be 50. Basically it is only 5 into 10. If you multiply, you will get the answer as 50. That was question number 22, A part. Now question number 22, B part is, Naomi has these 5 white cards and 3 grey cards. So these are the white cards, these are the grey cards. These are 5 white cards, these are 3 grey cards. Now she picks up 1 white card at random and 1 grey card at random. So from these 5 white cards and from these 3 grey cards, she picks up 1 card from each. Okay, calculate the probability of both cards showing the number greater than 3. So what is the probability of white card greater than 3 and what is the probability of a grey card greater than 3? We are going to first find out these two. So in the white cards, we can see greater than 3 are 2 numbers, okay, 4 and 5. So 2 cards out of 5. This is the probability of getting a probability of white being greater than 3. Same way, what is the probability of grey card being greater than 3? You have only 1 card which is greater than 3 in the grey cards. So it will be 1 divided by 3. So these are the 2 probabilities. And he has told you find the probability that both the cards show greater than this. So if both the conditions are being satisfied. For both, what you have to do is probability of white greater than 3 multiplied by probability of grey greater than 3. So this will give you 2 upon 5 multiplied by 1 upon 3, which works out to 2 over 50. So this is the answer, 2 over 50. Okay, the answer for this B is 2 over 50. That was question number 22. 23. 23 is 0.71 into 10 raised to n is equal to 71. So, and 2.3 into 10 raised to p is this. Find the value of this. So basically first we'll have to find out what is n and what is p. So 0.71 into 10 raised to n is equal to 71, right? Now if I want to make this left hand side also 71, so 0.71 into 10 raised to 2 I will do. Okay. Then it becomes 71. Am I right? 0.71 into 10 raised to 2 is 71. Now if I compare these two statements, I come to know that n is equal to 2. So I came to know that n is equal to 2. Same way 2.3 times 10 raised to p is equal to 0.00023. Okay. Here also what I am going to do is, this is 2.3. No, here I will try to make it 2.3. So to make 2.3, okay, I will have to shift this decimal 1, 2, 3, 4 times to the right. So I'll multiply this by 10 raised to minus 4. Okay, so 2.3 multiplied by 10 raised to minus 4 is this number, and this is equal to 2.3 into 10 raised to p. This 2.3 gets cut. Got it? Now we are left with 10 raised to p is equal to 10 raised to minus 4. The base are same, so index will also be same. So p is equal to minus 4. So I got p is equal to minus 4. Now we can handle this question. 0.067 okay, divided by 10 raised to n plus p. So n plus p means n is 2 and p is minus 4. So 2 plus minus 4 will be minus 2. Okay. So basically this calculation I have to do now. 0.067 into 1 upon 10 raised to minus 2. Okay. This division I am converting into multiplication. Right. So it will become into or 0.067 divided by 10 raised to minus 2. Okay. So I can write this way also. Yeah, one and the same thing. Okay. Now next step will be 0.067. Now this 10 raised to minus 2 I'll take in the numerator. Okay. So when I take in the numerator, this minus will become plus. So 10 raised to 2. Now this is very straightforward. 0.067 multiplied by 10 raised to 2 will be, we have to shift this decimal 2 places to the right. So the answer will be 6.7. Okay. So the answer for this is 6.7. Question number 23. And the 24th question, yeah, that's the last one. Now there's an algebraic statement x plus 3 the whole square plus a c is equal to x minus 3 times x plus 5 plus a 4x, and he has told you to find the value of c. Okay, so let us do this expansion. So a plus b whole square is a square plus 2ab in 6x plus b square, that is 9. So x plus 3 whole square is x square plus 6x of 9 plus c equal to, now if you multiply this out, if you expand this, this will be x square, 5x minus 3x is 2x, and 5 into minus 3 is minus 15, and this is 4x over here. So this is the expansion on the right hand side, right? X square gets cut, and this 6x will go with this 4x and 2x. Okay, this 2 makes 6x, this is gone. So you're left with 9 plus c is equal to minus 15. So c has to be minus 15 minus a 9. So c has to be minus 24. The answer for c is minus 24. Okay. So that is the completion of this paper 0862 paper 1 October 2024. Okay, so the part 2 of the video was dealing with this question number 15 onwards up to question number 24. Okay, so this was the from here we started. Okay, so that's all for today. Okay, so we have completed paper number 0862 in 2 parts, part 1 and part 2. This was the part 2. See you in the next video with some more paper solutions. Bye.